Now, today we are going to learn about number parity. Most of it is about odd and even numbers, but there are other strategies that we need to know as well, yeah? So if you take a look at your worksheet, you have a nice story here about the Japanese culture. They love 3, 5, and 7, you know, and all these are odd numbers. You know, when the Japanese do poems, they have a very famous poem format, 575. That means the poem has 5 syllables. The first sentence has 5 syllables, second sentence has 7 syllables, and the last sentence have 5 syllables. They have so many combinations of 3, 5, and 7. Now, one thing is that when you take note of odd numbers, right, and you use circles. Okay, let's say you have 7, the number 7, and we use circles to represent the number 7. Do you notice that it is not a perfect rectangle? And what happens if I have another odd number? Let's say the number 3. 1, 2, 3. Guess what? If I connect two odd numbers together, what will happen? I'll get a perfect rectangle, right? So what does this tell you? A perfect rectangle represents an even number. So if you have 7 plus 3, you get 10, which is an even number. So students, this is one way to visualize numbers, odd and even numbers interacting with each other. Over here, you have some rules. But let me warn you, please don't memorize them, okay? You don't really have to memorize all these. If you want to know what happens when you have odd plus odd, will it give you an even number or odd number? You can just use simple, small examples like 3 plus 3 equals to 6. And you will notice that odd plus odd equals to even. Even for multiplication, you don't have to memorize. If you want to know what happens if you have an odd number multiplied by odd number, 3 times 3 is 9. You will get an odd number. So odd times odd equals to odd. Okay? So all this is not required. You don't have to memorize all this. So students, we will be doing some examples, and you can see how numbers interact with each other. By the way, if some of you have a worksheet with different numbers, just don't worry about it, okay? Because if you have downloaded your worksheet last week, right, some of these numbers, right, okay, let's say it's 1125. In your worksheet is 1125, but please follow my updated numbers. Okay, we actually updated the numbers in the worksheet. So just follow whatever I'm showing you on my screen. Okay, if your worksheet shows a different number. So, students, in the first question, they're asking us, there are 5 consecutive odd numbers. The total sum is 10125. List the 5 odd numbers. Okay, so students, before we even do this, let's ignore the question first. I want to talk to you about average. Just imagine there are 3 students, A, B, and C. Student A has 1 sweet, student B has 2 sweets, student C has 3 sweets. Now, first I'm going to ask you, what is the total? Now, obviously, you take 1 plus 2 plus 3, and you'll tell me that there's a total of 6 sweets. And next, I'm going to ask you, how many people are there? How many people are there? N represents the number of people. The number of people is 3. A, B, and C, there are 3 people. Now we can find the average. What is the average? You will take the total divided by the number of people. 6 divided by 3, you realize the average is 2. And guess what? The average is the number in the middle, okay? It works for any consecutive sequence of numbers. For example, 1, 2, 3, 4, 5. Okay, let's say what is the total? 1 plus 2 plus 3 plus 4 plus 5, you get 15. How many people are there? There are 5 people, A, B, C, D, E. How do you find the average? Take the total divided by the number of people. The average is 3. And guess what? The average is actually the same as the number in the middle. Okay? So for any consecutive sequence of numbers, the middle number is the average. Even for consecutive odd numbers, take a look at this. Consecutive odd numbers. What is the meaning of consecutive? Consecutive means one after the other in sequence. Odd numbers, just be careful. They are looking for odd numbers. So what are we going to do? Okay, we already know that the middle number, the number in the middle is the average, okay? So let's take a look. Why don't we say, okay, let the average of these numbers be the letter n. And we already know that they are consecutive numbers. Therefore, the average is the number in the middle. And if you would like odd numbers, for example, 1, 3, 5, 7, 9, for example, then do you notice that the gap between them is 2, plus 2, plus 2, plus 2. The gap between the numbers is 2. Okay? So what we're going to do is this. We are going to let the first number be n minus 4. The next number is going to be n minus 2. The middle number is n. After that, we're going to have n plus 2 and n plus 4. So those are the 5 numbers that the question is talking about. And the number in the middle is actually the average. How do we find average? The average equals to total divided by the number of numbers. Okay, maybe I should have used a different alphabet, okay? Okay, let's just find the average. Average, which is the middle number, equals to the total, 10125. And how many numbers are there? There are 5 numbers. So what do we get? We get 2025. We have just found the number in the middle. So what are the 5 numbers? N minus 4 is 2021. N minus 2 is 2023. The middle number is 2025. Then 2027. And finally 2029. There you go. These are the 5 numbers. And they are all odd numbers. And they are all consecutive. One after another. Okay? Leanne, very good. I saw you typing in the chat. You had the answer even before I wrote it down. Anyone have questions about this? Raise your hand, students. Anyone? Okay, so what did we learn from this? We learned that the number in the middle is the average. But you must make sure that the numbers are consecutive. That means they must be in sequence. It will not work if you have numbers like that. 1, 3, 5, 9, 13. Yes, all of them are odd. But what is the gap between the numbers? They are not consistent, right? Can you see that the gap is not consistent? It will not work in such a case. Okay, you must make sure that the gap between the numbers are the same. Then the number in the middle will be the average. So let's try practice number 1, students. You have 3 consecutive numbers A, B, C, and they told you that A plus B plus C is greater than 700. What is the smallest possible value of A? Use whatever I've just taught you to solve this. Type your answer in the chat, everyone. I give you 2 minutes. Your time starts now. So students, let's first find the multiples of 3 that are greater than 700. How do you know that something is divisible by 3? You find the sum of digits. Okay, look at the number 700. 700 is not divisible by 3. You take the digits and you add them together, you get 7. This is not divisible by 3. However, if you try 702, you get 9, and this is divisible by 3. So you know that 702 is divisible by 3. What else is divisible by 3? Just keep on adding 3. Keep on adding 3, right? You keep on adding 3, you know that it's divisible by 3. All these numbers are divisible by 3. Next, what should you do? You should say, okay, let's try 702 divided by 3. And guess what? You are going to get an even number. So we are going to say this is even. We're not going to use it. What about 705? When you divide this by 3, you get 235. This is odd. And the question would like you to find odd numbers. Am I right? So you can say let the middle number, which is b, let b equals to 2, 3, 5. So therefore, A is smaller than B, 2, 3, 3, and C is bigger than B, 237. If you add all these together, A plus B plus C, you will get the answer greater than 700, right? You'll be getting 705. Therefore, the smallest possible value of A is 233. Well done. Let's see who got it correct. Josh, Matthew, Peter, Aiden, Jun-Yi, Kyler, Albert, Julian. Justin, is that a typo error, Justin? You typed 23. It's very small, huh? Leanne, very good. All of you got it correct. Okay? So, any questions, students? Can you see how useful it is to know that the middle number is the average? And then you just have to be careful. You just need to make sure you're getting an odd number instead of an even number. Okay? Now let's try practice number 2. The sum of 3 prime numbers is 86. List 3 possible sets of such numbers. Now they're talking about prime numbers here, students. What is a prime number? Anyone? What is a prime number? Let me know. Justin, yes. What is a prime number?
Can only be divisible by 1 and itself.
Thank you, Justin. A number that can only be divisible by number 1 and itself. So, let's make a list of prime numbers. Primes up to 86. Now, students, please take note that number 1 is not a prime number. The smallest prime number is number 2. And amazingly, it is the only prime number that is even. Okay? The rest of the prime numbers are all odd numbers. Why? For the simple fact that if you have any even number, it's going to be divisible by 2. Okay? You don't want that. For prime numbers, you only want them to be divisible by the number 1 and themselves. You don't want them to be divisible by the number 2. Okay? So all the prime numbers after 2 must be odd. So 2, 3, 5, 7, 11. Let's go. Let's continue. Just making a list. Up till 86, okay? Okay, I guess that's it. So, students, I've made a list of prime numbers up till 86. Okay, we don't want to go bigger than that because they're asking you they're telling you that the sum of 3 prime numbers is 86. Alright? They're asking us to identify 3 sets of prime numbers that add up to 86. Okay? Firstly, we know that 86 is an even number. And if you have 3 numbers, what are we going to do? You must have 1 even number and 2 odd numbers. Why? Because odd plus odd gives you even. So once you take odd plus odd gives you even, then even plus even can give you even again. Okay? What does this tell you? Immediately we know, students, the only prime number that is even is the number 2. The other 2 prime numbers are going to be odd. So we are going to just write down the sum of the other 2 primes must be 84. Okay, so let's form one set. I know that the number 2 is going to be involved. Let's try for the smaller numbers first. 2 plus 5 plus 79. These 3 numbers will add up to 86. And as you can see, the sum of the other 2 prime numbers is 84. Okay, so that's one set for you. Why not you guys help me to find the other two sets. The other two sets of numbers. I know that the number 2 is definitely going to be in there. And then you have to find the other two prime numbers that add up to 84. Okay, students, type your answer in the chat. Let me see. Now, students, there can be many different answers, okay? As long as all the numbers you use are prime numbers and they all add up to 86. So, you know, the simplest ones would be the smaller ones, like, for example, 11 and 73. You notice that 11 and 73 gives you 84. And the next one would be 13 and 71. Gives you 84. Other possible answers, okay, for example, Jun Yi said 47 and 37. Yes, it gives you 84. Any other possible answers? Let's see. Josh gave 17 and 67. Yes, that gives you 84. Aiden, 31 and 53. Yes, correct. Yeah, 23 and 61. Matthew, yes, you got it. So students, as long as the other two numbers add up to 84, okay, Aiden said 41 and 43. Correct. Yeah. Jun Yi said 53:31. Yes, that works. Okay, students, so this is just an exercise to get you familiarized with prime numbers. But more importantly, when you see 86, you know that 86 is an even number. You should be able to deduce that you're going to add an even number and two odd numbers. That is what the main concept should be. Okay? Any questions, students? Raise your hand. Okay, let's move on to question 3, okay? Now, the number 1995, if it was expressed as a product of its factors, and various combinations of these factors are going to be used to form the side length of triangles. How many different triangles can we form? Now, before we start this question, I guess it is important for us to break down number 1995 into its factors, okay? So we know that 1995 equals to 399 times 5. Now let's further break down the number 399. Number 399 equals to 133 times 3. Can we further break down the 133? Yes. 133 equals to 7 times 19. Now we cannot break down any of these numbers. Let's circle all of them. They are all prime numbers. We have found the prime factors of 1995. So we can say 1995 equals to 3 times 5 times 7 times 19. So students, we are going to make use of all these numbers, form some combination of them, and we can form the side of triangles. For example, we can just take these three numbers, 3, 5, and 7. That will give us a triangle, right? We can form a triangle with sides 3, 5, and 7. No problem. Can we form a triangle with the sides 3, 7, and 19? Yeah. 3, oh wait, sorry, not 3, 3, 7, and 3. Okay, let me take 7, 15, and 19. How did I get 15? I took 3 times 5 and I combined them together. So I can form 7, 15, and 19 is the longest side. No problem. What else can I do? I can form a triangle with 5, 19, and 21. How did I get 21? 3 times 7, that's 21. So all these are possible triangles that I can form. Now students, there are other combinations of numbers. For example, 3, 5, and 19, 3, 7, and 19, maybe even 5, 7, and 19. Now I'm going to tell you this, students. We are not able to form triangles using those combinations. Can anyone explain why? Raise your hand. Anyone knows? Want to guess? Why can't I use the others? Yes, Josh. Why?
Because two sides of the triangle must always be bigger than the last side.
Thank you, Josh. Very good explanation. Now, students, look here. Whenever you form a triangle, okay, let's say I have a triangle with a base of 20 cm. If I have the sum of the other two sides, okay, let's say the other one side is 5 cm and another side is 10 cm. Okay, let's say this is 10 cm and this is 5 cm. Can they even touch each other? No, they can't even touch each other. How are we going to form a triangle? So what did Josh say? Josh said that the sum of the other two sides must at least be bigger than the longest side. So if we had something like 11 plus 10, okay, at least we stand a chance. 11, 10, at least they can touch each other, right? So students, if you look at the other three examples that I've written down, do you notice that this is the longest side? These two can't even add up to be more than 19. These two can't add up to be more than 19. These two cannot add up to be more than 19. They are out. We cannot make triangles like that. So we can only make 3 triangles. The answer is 3. We can form 3 triangles. So what did we learn here, students? We learn how to break down the number 1995 by using this method. This method is called prime factorization. You are trying to get the prime factors of a number. So you break them down slowly until you get all the prime numbers. So once you have the factors, you can use these factors to form your triangles, okay? Now let's take a look at question 4. Okay, this requires you to visualize a little. Students, they would like to ask you in which row and which column is the number 2022. And if you look at the table, do you spot a pattern? In the first row, the numbers are moving from left to right. It is getting bigger and bigger from left to right. In the second row, the numbers are getting bigger from right to left. 10, 12, 14, 16, from right to left. And then it goes from left to right again. Then it goes from right to left again. That means you have 30 here and 32 here. Now, if you continue this pattern, you'll have 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64. It goes on and on and on and on and on and on until the number 2022 is somewhere. Your job is to find out which row and which column is number 2022 located in. I'll give you 2 minutes. Come everyone, type your answer. Your time starts now. Okay, Koji, my first question to you is, do you spot a pattern?
Kind of.
No? Kind of? Okay.
Yeah.
So let me ask you then. Look at row number 1. Look at row number 3. 1 and 3. Are they odd numbers or even numbers?
Even.
1 and
Oh, no, no. Wait, you mean the 1 and 3 or the 2, 4, 6, 8 or an 18?
just the number 1 and the number 3.
Oh, no.
Are they odd or even?
They're odd.
Very good. So if I were to call this row number 1 and row number 3, can I say that these are odd numbered rows?
Yeah.
And if I were to call this row number 2 and row number 4, can I say that they are even numbered rows, okay? Okay, so students, let's look at the rows. For the odd numbered rows, Koji, do the numbers get bigger from right to left or left to right?
For odd?
Odd, yes, odd rows.
Yeah, from left to right.
Yes, left to right. They're getting bigger in this direction. And for even numbered rows?
Right to left.
Right to left. Now, for the odd numbered rows, which column do you start from? They always start from which column?
B.
B. Okay, students, look. In the odd numbered rows, they always start from column B, and from the even numbered rows, they always start in
D.
D. Very good. Okay, so this is the pattern that we need to notice. Now, all the numbers you see in the table, are they even or odd?
Even.
Even. And they are asking you to find the number 2022. So, how many even numbers are there from 1 to 2022?
$1,011.
Yes, okay, because from 1 to 2022, you have 2022 numbers. Half of them are odd and half of them are even. So if you would like to find the number of even numbers, just divide it by 2 and you realize that you have 1011 numbers altogether in the table up till 2022. Do you agree? Koji?
Yeah.
Okay, so we have 1011 numbers altogether. How many numbers are there in each row?
4.
Very good. So let's find the row number. Okay, because there are 4 numbers in each row. Let's try to find which row the number 2022 will appear in. So what I
1011 divided by 4.
Yes. Do you think the number 2022 is in row 252 or is it in row 253?
253.
Why?
Because there's a remainder.
Very good. Okay, so students, look. The row number, okay, let's find out how many groups of 4. Let's call these groups of 4. Groups of 4. There are 252 groups of 4 numbers, but there's a remainder of 3. The number 2022 is part of these remaining 3 numbers. So therefore, the row number should be 253. Now it is time to find out the column. Look at row 253. Is it an odd row or is it an even row?
Even.
No. 253.
Oh, odd.
It's
Right.
odd. So for all your odd rows, what is the pattern? You start from column
D.
no
No,
odd-
no, no. No, no, B.
B,
Okay.
and you go from left to right. Yes.
Yeah.
You have remainder 3 numbers. So which column will you end up in?
D.
Yes, very good, Koji. You solved it. We are in row, so the number 2022 is in row 253, column D, right? All right, thank you, Koji. Well done. Let's see who got it correct. I can see that Aiden found the column. Justin, you got it correct. Albert found the column. Who else? Yeah, I think that's it. So students, please take note of the pattern first, and then you can group the numbers together. You must find how many even numbers are there altogether, because all the numbers here are even. You're dealing with 1011 numbers altogether, and you put them in groups of 4, because each row has 4 numbers. So when you have a remainder, you have to continue to the next row. You cannot squeeze everything into row number 252. It will continue into row number 253. And since you know that row number 253 is an odd row, the numbers will start from column B. Okay, so for example, the number 2018 is here. Then the next number is 2020, and finally 2022. It will be in column D. Okay, these are the remaining 3 numbers that do not have a group. Any questions, students? Raise your hand. Let me know. Okay, now let's look at question 5. Students, look at the pattern again. We have to spot the pattern. When you have one number, you start with the number 1, and then 1 plus 1 is 2, right? When you have 2 numbers, you start with the number 2, the next number is 3. When you have 3 numbers, you start with the number 3. 4 numbers, you start with the number 4. So if the question is asking you for n numbers, which number should you start with? Gwen, can I ask you, which number should you start with? You have n numbers. So which number should you start with, Gwen?
The first one.
Okay, let's do this again, Gwen.
The amount of numbers there are.
Okay, so if I have 4 numbers, I start.
I think it's n line.
Very good. Okay, so if you have n numbers, you start with n. So let's say you have 4 numbers, you start with 4, right? Then you must multiply it by what? What is the next number that you have to multiply it? If the first number is 4...
5 is like the average, right?
No. If the first number is 4, the next number will be 5. If the first number is 5, the next number will be...
Wait, what? I thought it was like average. Like, cos 2 plus 4 divided by 2 is 3, what?
We are looking for pattern here. If I have 3 numbers, I start with 3. The next number is 3 plus 1.
Okay.
The next number is 3 plus 1, right? If I have 4 numbers, I start with 4. The next number is 4 plus 1, which is 5. If I have 6 numbers, the next number will be 6.
7.
7. You have 7 numbers.
So it's n plus 1.
There you go. Was this easy? You just needed to spot the pattern, right? Alright, you are correct. Well done, Gwen. Asher, I saw your answer. Very good, Asher. So students, it's easy to spot the pattern. So next time when anyone asks you, please add up all the even numbers starting from 2, okay, let's say up till 1000. All the way till 1000. Guess what? How many numbers do you have here? You have 500 numbers, right? Then the next number is 501. That's the answer. You don't have to add them one by one, right? You can just take 500 times 501. Okay, this works for any set of consecutive even numbers starting from 2. Okay? Students, can I ask you this question? Can you find what is the... Using this formula, okay, I don't want you to use any other formula. I don't want you to use Gauss summation. Don't use that. Just use this formula. Tell me how to find this answer. Wait. Now let's just start from 80. All the way till... 200. Tell me what is the answer, please. Tell me what is n times... What is n? Tell me what is the value of n. No. Okay, just tell me the final answer. Tell me what is the sum. What is the final answer here, please? Tell me what is the final answer. I give you 2 minutes. Type your answer in the chat. Now, Lian, let me ask you some questions. Okay, Lian, how many numbers are there from 1 to 200? Just how many numbers are there?
200.
200. Out of all these 200 numbers, how many of them are even numbers? Half of them are odd, half of them are even, right? So how many even numbers are there, Lian? Hello?
100.
Lian, are you paying attention? Why it take so long to answer that? Okay, Lian, there's 100 even numbers, okay? So if I were to add all the numbers from 2 all the way till 200, what formula can I use? I can use this formula, right, Lian? So what?
100
Times?
202
Sorry, again?
divided by 2.
You just...
202 divided by
No,
2.
you don't even have to do that. N is 100. What is n plus 1?
100 times 101.
Correct. You can just use this formula. So it's 100 times 101. Now you have found all the numbers, the sum of all the numbers from 2 to 200. But am I starting from 2 in my question here? Am I starting from the number 2?
No.
No. So how am I going to find the answer from 80 to 200?
209.
Yes, very good. So you
79.
78 because it's all even numbers, right, Lian? So now
Yeah.
you need to find all the numbers from 2 all the way till 78. Okay, then you tell me how many even numbers are there from 2 until 78?
Uh, 78 divided by 2.
Correct. 39 times. Use this same formula, Lian.
Times 49
Whoa.
plus 1.
Wait, 39? Did you say 39 plus 1 or 49? 39, right?
39.
Correct. Very good. Very good. So, Lian, what's our final answer? We just need to take this minus this. Am I correct?
Yeah.
Well done. Okay, good job, Lian. So, students, let's find out what's the correct answer. 100 times 101. We'll get this. 39 times 40 will give us 1560. Therefore, the final answer is 9944. Okay? Any questions, students? Please take note, this formula only works if you start from the number 2. So if I'm starting from 80, you can't just apply this formula just like that. Okay, you have to start from the number 2. Okay, everyone? Any questions? Now, let's try the next one. Question, example 2. Okay, you have to determine which of the statements are true, right? So, why don't we do an example first? Let's take a look at statement number 1 first. If A plus 5B is even, then A minus 3B is even. Students, whenever you're not sure, just think of odd and even numbers. Assuming A is odd, B is also odd. Odd plus odd will give you even. So let's apply this onto the next term. A is odd and B is also odd. Odd minus odd is also even. So we know that this is true. If this is true, this must be false because they are telling you that this is odd. Okay? So we have already determined this is true, this is false. Why not you use the same method, figure out point 3 and point 4 and give me your final answer. Come everyone, type your answer in the chat. Now, students, some of you are giving me 2 answers, A and B. Why? I think I know why. Because if you think that this and this is true, then either A or B will work. Correct? Okay, let's see who's correct. Are you ready? Now, students, this is not a logic question. It's more of a odd and even number question. Matthew, yes, question? Matthew, you raise your hand.
The reason why I chose to answer is because they said determine which of the following is or are true.
Yes. So when they say is or are, they're talking about all these. So if there's only one correct statement, then it is is. If there are 2 correct statements or more, then it is are. Correct?
Yeah.
Yes. Okay. All right. So let's take a look, students. Now, can we just imagine? Okay, let's say, how do we get odd here? Let's say A is even, B is odd. If A is even and B is odd, then we will get odd. if A is even, B is odd, then we will get odd. So is this true or false? They are saying that it's even. This is false. If this is false, then this should be true, because they say that it is going to be odd. So which are the two statements that are true? Statement 1 and statement 4. So can I give my answer as A? No. This is wrong. The correct answer is B. Okay? Well done, Julian, Josh, Kyler, Gwen, Matthew. Matthew gave me 2 answers, not counted. Albert, Aiden, Koji, Justin. Good job. All of you got it correct. Okay? Well done, well done. So students, whenever you're not sure, just substitute odd and even. Okay? And even better, if you don't know how to substitute odd and even, just use numbers. Use real numbers. For example, A plus 5 times B. So you are trying to tell me that A is even and B is odd. What will you get? Just work it out. You will get an odd answer, right? So if A is odd, if A is even and B is odd, the answer should be odd. If you don't know, use numbers. Use real numbers. Okay? Alright. Now let's do practice number 6. The numbers 1, 2, 3 until 9 are randomly rearranged, and they are labeled as A1, A2, A3 until A9. Show that A1 minus 1, A2 minus 2, all the way till A9 minus 9 will be an even number. Now, before we even begin, let me explain to you something. When I write something like that, when you have 2 brackets side by side, it means multiply. Okay, what does it mean? It means 5 minus 1 is 4, multiplied by 6 minus 3. So when you see brackets side by side, just know that it is multiplication. Multiplication, okay? Now, firstly, what if we suppose, okay, let's pretend, okay, let's suppose that whatever the question gives you, all the way until 9, is the outcome is odd. So if you multiply 9 numbers together, and if you would like the outcome to be odd, guess what? Then all the terms must be odd. Why? Because if I multiply 2 odd numbers together, odd times odd gives me odd. No matter how many odd numbers you multiply together, the answer is always odd. So if this expression is odd, that means all the numbers inside must be odd. The moment you have one even number, that's it. The answer will be even. Let's try, okay? Let's try. 3 times 3 is 9, times 3, 27, times 3. You still get an odd number. The moment you multiply by an even number, your answer is already even. So if you would like this outcome to be odd, all the terms must be odd. You cannot have anything that is even. You can't have an even number. Not a single even number. Okay? Now, from 1 to 9, we know how many odd numbers are there. 1, 3, 5, 7, 9, 5. How many even numbers are there? 2, 4, 6, 8, 4. There are more odd numbers than even numbers, right? So, since there are more odd numbers than even numbers, at least one of these expressions, at least one of these A1, A2, A3 in brackets will be even. And what did I say about even numbers? The moment you have one even number, the entire result will become even. Therefore, it is not possible for this to be odd. The outcome of this will definitely be even. There you go. So this shows you how multiplication works between odd and even numbers. And of course, there's some logic there. You need to know that there's more odd numbers than even numbers. No matter how you pair them up, one of those pairs will be even. The moment you have one even number, that's it. Everything becomes even, okay? Because you're multiplying all of them together. Julian, the A, okay. Julian is asking, what is this? We are just we are just having some different terms, okay? And we are using 1 to 9, right? So we are saying that, okay, maybe A1 equals to 9, A2 equals to 3, A3 equals to 1, A9 equals to 8. We are randomly assigning a value to the letter A, A1, A2, A3, all the way until A9. Then what we are doing is we are taking A1 minus 1 times A2 minus 2 times A3 minus 3, all the way until A9 minus 9. So if I say that A1 equals to 9, that means I'm taking 9 minus 1. If A2 equal to 3, then I'm taking 3 minus 2. If A3 equals to 1, then I'm taking 1 minus 3. All the way until if A9 equals to 8, then 8 minus 9. So we're just randomly assigning numbers to A. Okay, Julian? So the letter A is like algebra. It's like the letter X. X can be any number, right? It's just using the letter A this time round. Okay, let's try the next question. Example 3. Determine if this outcome is even or odd. So, let's see. Students, why don't I just let you think about it first? Just take 1 minute to think about it. Do you think this will be even or odd? Can you type your answers in the chat? Justin, why do you think it's odd? Or is it just a guess?
Mostly I guess, but then I found out that like if the number you're trying to square is odd, the result will be odd, and if it is even, it will be even.
So, okay, so Justin said that if you square an odd number, for example, 3 squared, which is actually 3 times 3, you will get an odd number. But if you have an even number squared, you will get an even number. That's what you're saying, right, Justin?
Yeah.
Very good. You're not wrong at all. Okay, you're not wrong at all. So based on this, somehow Justin thinks that the whole thing will give you an odd answer. Let me ask Peter. Peter, you feel that it is even. Why do you feel that it's going to be even?
I sort of already worked it out, but
Oh, you worked it out.
yeah,
It's such a huge sum. How do you work it out?
I just looked at what gives odd and even answers and then found the pattern.
Wow. Okay, so Peter tried to work it out and tried to spot a pattern. Let's see who is correct. Now, students, let's take a look, shall we? Firstly, we know that from 1 to 2022, half of the terms are going to be odd. Half of them are going to be even. So let's find out how many odd numbers there are. Number of odd numbers. Just divide by 2 and you get 1011. There are 1011 odd numbers from 1 to 2022. Let's take a look at all the odd numbers. Up till 2019, up till 2021. So these are all the odd numbers. Let me ask Jun Yi. Hi, Jun Yi. Jun Yi, how many odd numbers do I have here? From 1 until 2021. I mean, we have just calculated it, didn't we? Half of them are odd, half of them are even, right?
Yeah.
So how many?
1011.
Yeah, there are 1011 odd terms here. Now, Justin mentioned something. Justin mentioned that when you take an odd number and you square it, the outcome is going to be odd or even.
Based on the number.
It depends on the number. No. Look at 1 times 1. 1 times 1 is 1. 3 times 3 is 9. 5 times 5 is 25. Don't you see that all of them are going to be odd or even?
Odd.
Yes. When you take an odd number, you square it, the outcome is odd. So do you agree that this is going to be odd? This is going to be odd. This is going to be odd. Everything is going to be odd. Yes or no?
Yes.
So everything is going to be odd. How many odd numbers are you adding together?
1011.
1011. Do you think the outcome is odd or even? This is odd. This is also odd, right? 1011 is also odd, right?
Odd.
Yeah. Okay, the outcome is odd. Now let's look at the even numbers. 2, 4, 6, all the way till 2020, 2022. How many even numbers are there here altogether?
1011.
And for every even number, if you square it, will you get odd or even?
Even.
Even. So do you agree that every single one of these numbers here are even?
Yes.
How many times are you adding together the even numbers?
1011.
What outcome will you get?
Even.
Even. So the outcome from all the odd numbers is odd. The outcome from all the even numbers are even. You add them all together. What is the final outcome?
Odd.
There you go. All right. Thank you, Jin Yi. Well done. Okay, so students, this is how you do it. Just separate the odd from the even, and then you realize that it's going to be odd. Okay? Any questions? Raise your hand, students. Okay, now let's try practice 7. Okay, use whatever you have learned and just give me your answer. Everyone type your answer in the chat. Your time starts now. So, Surabi, come, let's determine whether it's even or odd, okay? First, I would like to ask you, number 2, is this an even or an odd number?
Even.
So if I have an even number multiplied by an even number, what will I get? Even or odd?
Even.
Continue multiplying by even number. Is it still even?
Yes.
Continue. Is it still even? So if I multiply this, if I multiply this 2001 times, will it still be even or odd?
Yeah.
So this is even. Okay, so this is even. Okay, very good. So 2 to the power of 2001 equals to an even number. What about an odd number? If I keep on multiplying an odd number by itself, odd times odd times odd times odd times odd, will I get odd or even? Odd times odd is odd, right?
Yeah.
Times odd again.
Still odd.
Still odd, still odd, still odd, still odd. So in the end, what will I get? Odd or even?
Odd.
What about for 7?
Also odd.
What about for 9?
Also odd.
So if you add everything together, Even plus odd plus odd plus odd. What is the final outcome? You can do it two at a time. Even plus odd is?
Even.
Even plus odd. Okay, come, let's use numbers. Use numbers. Even plus odd. What do you get?
Odd.
Plus odd again?
Odd.
Plus odd again?
Even.
So final answer is even or odd? Look at all this. You can just...
Odd.
Yes, it is odd. Well done, okay? You got it, Surabi. Any questions about this?
Mm.
Okay, thank you, Surabi. So students, well done. All of you who said it is odd, you are correct. Good job, okay? Actually, it is a 50-50 chance. Even though you didn't know what you're doing, you could have guessed it. Okay, never mind. So now you know. Now let's look at question 8. Question 8 states that there are 4 whole numbers, A, B, C, and D. Now obviously these 4 numbers are different because they are different alphabets, right? So you have 4 different whole numbers, A, B, C, and D. And they're telling you that A squared plus B squared equals to C squared plus D squared. So let's just do an example. Okay, let's say A is 4. 4 squared, let's say B is 2 maybe, equals to C squared. Let's say C is 1 plus D squared. Let's say D is 5. I mean, this is definitely not going to be equal to each other. Okay, 4 times 4 is 16. 2 times 2 is 4. 1 times 1 is 1. 5 times 5 is 25. I know this is definitely not equal to each other, but just assume that they are equal. Okay, they're just trying to tell you that we don't know what is A, we don't know what is B, we don't know what is C, we don't know what is D. Our purpose here is not to find what is A, what is B, what is C, and what is D. Our purpose here is only to determine if they are odd or even, and if they are prime number, or if they are a composite number. Now, let me tell you what is a prime number. I think everyone knows what is a prime number, right? Prime number only has 2 factors. Number 1 and itself. That means you can only divide it by 1 and itself. What is a composite number? A composite number is a number with more than 2 factors. That means a composite number can be divided by more than 2 different numbers. Okay? So, let's observe this question. They're telling you that A squared plus B squared equal to C squared plus D squared. So, since we already know that A squared plus B squared equals to C squared plus D squared, if A plus B is odd, okay, if A squared plus B squared is odd, then since they are equal, don't you think that C squared plus D squared should also be odd? Because they're equal to each other, right? Or you can say that if A squared plus B squared is even, then we should also expect C squared plus D squared to be even, since they are equal to each other. Therefore, A plus B plus C plus D. If A and B are odd, then C and D should also be odd, right? So it should be odd plus odd. Or what if they are even? If A and B is even, don't you think that C and D should also be even? Then we will end up with even plus even. No matter whether it is odd plus odd or even plus even, the answer is always going to be even. Aha! Now we know that A plus B plus C plus D is definitely going to be even. So let's get rid of this odd number. Get rid of the odd options. Now I think we just need to find out whether it is a prime number or a composite number. Students, can you type your answer? Is it A or C? Koji has already given me his answer. How about the rest of you? What do you think? Prime or even? Sorry. Prime or composite? A or C? Think about it. What is your answer? A or C? Surabi, I got your answer. Albert, I got your answer. Matthew, I got your answer. Julian, Josh, I got your answer. Peter, I have your answer. Justin, I have your answer. Very good. All of you are correct. Okay, the answer is C. It cannot be a prime number. Who wants to explain to me why the final answer cannot be prime? Who wants to explain this to me? Why can't it be prime? Yes, Justin. Why?
Because if a number it needs every number that is even besides 2 is not prime. But then the answer can't be 2 because it needs.
Because A plus B plus C plus D is definitely more than 2, right? Correct. Thank you, Justin. Surabi, is your answer the same as well? Is your explanation the same?
Yeah.
Very good. Well done. Students, look. Even if we say that A is 0, B is 1, this is 2, this is 3, no matter what, students, okay, A plus B plus C plus D is definitely greater than 2. Therefore, the answer is not going to be prime. Because 2 is the only prime number that is an even number. Anything bigger than 2 is going to be composite. So the answer is C. Okay, students, well done. Those of you who got C, good job. Okay, cannot be prime. 2 is the only even prime number. Now let's do example 4. How many numbers from 1 to 98 can be expressed as the difference of 2 squares? Okay, firstly, let's draw a square. Students, how do you find the area of a square? If the side length is 2, you want to find the area, you just take 2 times 2, right? If the side length of the square is 3, you want to find the area, you take 3 times 3, right? Guess what? These numbers 4 and 9, they give you the area of a square. What do you call them? You call them square numbers because they give you the area of a square. So when you have 2 to the power of 2, you call it 2 square. 2 square. The answer is 4, you get a square number. 3 to the power of 2, this is 3 squared. The answer is 9, you get a square number. So now you know why we call it square numbers, because they always give you the area of a square. So that is a square number. What is the meaning of difference of 2 squares? The difference of 2 squares, that means, let's say this is a square number and this is another square number. What is the meaning of difference? Finding the difference means minus. Okay? And let me introduce you to this formula. Whenever you see m square minus n square, you can simplify it to m plus n multiplied by m minus n. M plus n times n minus n. Let me show you an example. For example, m is 5, n is 3, equals to m plus n multiplied by m minus n. That means 5 plus 3 multiplied by 5 minus 3. And what if you work this out? 5 times 5, 25. 3 times 3, 9. Don't you get the same answer, 16 as well? So this works. This works. So whenever you see the difference of 2 squares, m square minus n square, you can make use of m plus n times m minus n. Okay, so this is the most important formula that you need to know for this question. Now, moving on. Now that we know what is the difference of 2 squares, they're asking you, how many numbers from 1 to 98 can be expressed as the difference of two squares. Now students, let's observe this. Okay, if let's say m is 5 and n is 3, what will you get? You get an even number times an even number. Let's do another example. You'll get an odd number times an odd number. Do you notice that both of them are either odd, or both of them are either odd or even? Both of them can be even, or both of them can be odd. You will never get even times odd. You will never get this. It's either both even or both odd. So let me write this down. M plus n and m minus n are either both odd or both even. So if both of them are odd, what can we say? Okay, then we will realize that odd times odd equals to odd. That means the answer, this answer will be odd. Okay, then m square minus n square will be odd. Right? So, if this is odd, how many odd numbers are there? From 1 to 98. From 1 to 98, how many odd numbers are there? You just divide by 2. Because half of them are odd, half of them are even. That means we have 49 numbers. So we have already found that if both of them are odd, then there are 49 possible numbers from 1 to 98 that can be expressed as a difference of two squares. What if it is even? If both of them are even, then m square minus n square will be, okay, let's see. If both of them are even, even times even is even. But don't just assume that it's going to be even. There's something more. Let's do some experiments, shall we? Let's say m is 2 and n is 0. Two times 2 equals to 4. Now let's try to slowly increase it. 3 and 1. You'll end up with 4 times 2, 8. Slowly increase it even more. 4, 8, 12. Can you start to see a pattern, students? Can you see a pattern? 16. Do you notice that all of them are multiples of 4? Right? So I'm not just going to write even, I'm going to write down they are multiples of 4. Okay? So let's find how many multiples of 4 are there. Number of multiples of 4. 98 divided by 4. We will get 24 remainder 2. So you have 24 possible multiples of 4. So students, can I say that the total number of numbers is 49 here plus 24? Who thinks the answer should be 73? Raise your hand. Or who thinks that 73 is wrong? Students, 73 is wrong. Albert, can you tell me why 73 is wrong? Albert, do you know why? Oops, he got disconnected. Okay, 73 is wrong. The answer should be 72. Can anybody tell me why did I minus 1 here? Let me show you, let me give you a hint, okay? Did you see me write this just now, everyone? Is the question asking you 0 to 98 or 1 to 98? 1 to 98, right? So can I write 0? I'm sorry. 0 is not accepted. So this will not exist. The number 4 will not exist. Okay? Oh wait, stop. How many numbers from 1 to 98? Oh, okay, so sorry, students, the answer is 73. My mistake. If you read the question carefully, they don't really care what is the value of m and what is the value of n. They only care the outcome. If the outcome is 4, then it's accepted. The answer is 73. Okay, the answer is 73. Well done. Okay, looks like Albert is back. Albert, sorry, my mistake. The answer is 73. I was thinking that actually this 2 plus 0 times 2 minus 0 equals to 4. I was thinking that you cannot accept 0 because the question is asking 1 to 98. But actually they are asking you what numbers from 1 to 98 can be expressed as a difference of two squares. So I was thinking that m and n must be from 1 to 98. But actually they don't care about that. They only care about the outcome. The outcome must be from 1 to 98. So number 4 is accepted. And n can be 0. Okay? So the answer is 73. Practice 9. How many numbers from 1 to 199 can be expressed as a difference of two squares? So once again, students, let's just write down the difference of two squares. And we know that this and this will either be both odd or both even, right? If both of them are odd, then this will be odd. So you just need to find how many odd numbers are there. But if both of them are even, then the result will be a multiple of 4. So you must find out how many multiples of 4. Then you can tell me your final answer. So students, can you work out your final answer and let me know? Type in the chat. Quite straightforward. How many odd numbers are there from 1 to 199? Now I hope you're not going to try to take 199 divided by 2. You can just pretend that it's from 1 to 200, right? You just take 200, divide by 2, you get 100. You have 100 odd numbers. How many multiples of 4 are there? Well, similarly, you don't have to use 199, right? You can just, okay, actually you have to use 199 because 200 happens to be a multiple of 4. 200 divided by 4 is 50. Now, obviously, you cannot count the number 200. That means there's 49 multiples of 4. Add them together. You get 149. There you go. Okay. Well done. I see the correct answers from Peter, Albert, Justin, Koji. Good job. Now, students, let's try question number 10. Given that a minus b is 1995, and they are saying that a and b are prime numbers, find a plus b. So, Students, how should we start off? Ask yourself, should A be odd or even? Should B be odd or even? They already told you that A minus B is 1995. Ask yourself, is A and B odd or even? And then what is A and what is B? Type your answer in the chat. What is A plus B? I give you 2 minutes. Your time starts now. Alright, Kyla, let's take a look, okay? A minus B is 1995. 1995 is odd or even?
Odd.
Do you think A should be odd or A should be even? Okay, let's do an experiment. What if A is even minus odd? Will you get odd or will you get even? Okay, let's just do experiment. 4 minus 3. Will it be odd or will it be even?
Odd.
Odd. Very good. But they said A and B are prime numbers, right?
Yeah.
What is the only prime number that you know which is even?
2.
2 minus something equals to 1995. Possible or impossible?
Impossible.
Impossible. Okay, so this is out of the question. So do you think it should be odd minus even instead?
Yeah.
Very good. So we can say A minus B equals odd minus even, which is equals to odd. So what do you think is the even prime number?
2.
2. What do you think is A?
1995.
Oh,
1997.
yeah. So therefore, A plus B should be...
1999.
Yes. Easy or not?
Yeah.
Well done. You got it, Kyla. Good job. Okay. So, students, that was an easy one. Anyone has any questions? Raise your hand. Okay, very good. Koji, Leanne, Matthew, Justin, Julian, Peter, and Aiden, and Albert. And Josh, you got it correct. Well done. Okay. Now, let's try our final question for today. A, B, and C are prime numbers. Okay, don't be scared. Do not be scared when you see this. This means power. This is a power. Power, that means you just multiply it 2 times, or you can multiply it 3 times. Or if the power is 5, then you multiply 5 times, okay? If the power is B, then you have to multiply B times. B times. B times, okay? That's all that it means. Don't worry. Okay? So for example, if B equals to 5, then what is B to the power of B? That means B to the power of 5. 5 to the power of 5, that's it. So don't be scared when you see that, okay, students? And when you write down alphabets side by side, what does it mean? That means multiply. Okay, A, B, C, D. That means A times B times C times D. That's it. So when I write down A, B, B, C, what does it mean? It means A times B to the power of B times C. That's all it means. Okay, so now you know what it means. They say A, B, C are prime numbers, and they're telling you that A, B, B, C plus A equals to 2000. They want you to find what is A plus B plus C. Okay? So, can I ask for volunteer? Peter. Hi, Peter. Peter, can you tell me what is the only prime number that is even?
2.
2. Okay, let's write it down. Since 2 is the only even prime number, let us do a test. Okay, let's try A equals to 2. Now, why do you think I'm trying A equals to 2? You look here. When we have A being an even number multiplied by 2, okay, let's say A is an even number. Then B and C must be odd or must be even. What do you think, Peter?
Doesn't matter.
It has to be odd. Why am I saying that? Because A, B, and C are all prime numbers, yes?
Yeah.
So if A is the even prime number, B and C should be odd or even?
Odd.
Odd. Now the moment you multiply odd numbers by even numbers, the outcome will be odd or even?
Even.
Even. So students, look here. The entire thing is going to be even. And if this is also even plus even will give me, Peter? Even. And don't you see that 2000 is even? So it makes sense, right? Okay, so let's say A equals to 2. Now, if A equals to 2, what am I going to have? I'm going to have 2 times B to the power of B, C, plus 2 equals to 2000. Therefore, 2BBC equals to 1998. There you go, because we're getting rid of the number 2. Then B to the power of BC equals to 1998 divided by
2.
2, because we're trying to get rid of this 2 here, so we're going to divide by 2, which gives us 999. Now there are a few scenarios. Okay, there are a few ways to get 999. 999 could be derived from 1 times 999, or it could be 3 times 333. It could be 9 times 111. Could be 37 times 27. Look at all these, Peter. Which one do you think is most likely? Remember, B and C are prime numbers. Which one do you think is most likely, the one that we're going to use?
37 and 27.
Very good, because 37 is a prime number. But is 27 a prime number?
No, it's a cube number.
Very good. So if it is a cube number, I can say that since 27 equals to 3 to the power of 3, therefore B equals to
37.
37. No. Remember, we have B to the power of B here.
Oh, 3.
Very good. B equals to 3. Students, look here. Doesn't this look a lot like this? 3 to the power of 3. B to the power of B. So B should be 3. And therefore, C should be
37.
37. Very good. Well done, well done. Therefore, A plus B plus C should be 2 plus
3.
and 37.
37.
Gives us?
42.
There you go. Well done. Any questions, Peter?
No.
Okay, thank you, Peter. What about the rest of you? Anyone have questions? Raise your hand. Okay, so it's very logical, students. This topic is very logical. Ask yourself, even plus even equals to even. There you go. Even plus even equals to even. Number 2 is the only prime number that's even. So you let A equals to 2. Makes sense. And you slowly work your way down, right? And of course, another thing that you need to be smart about is you need to be smart about choosing your factors. Choose the factors that has a cube number, 3 to the power of 3. Okay, by the way, this is called square. Power of 3 is called cube. This is called square. Squared and cube. Okay, so choose the cube number and choose the prime number. Then you can let B equals to 3. Alright. Okay, well done today, everyone. What did we learn? We learned about how odd and even numbers interact. And don't memorize. Do not memorize. If you forget, just use some small examples. Odd times even. I forgot. Is it odd or is it even? Odd times even. Just use 3 times 2. You get 6. So, odd times even is even. Okay? No memory required. No memorization required. And what else did we learn? We learned what are the difference of squares. We learn prime numbers. We learn composite numbers. So many things, right? We even learn how to do prime factorization, how to split up a number into the prime factors. So students, and we also learn about triangles. If the one side is very long, the other two sides must add up to be longer than the longest side so that you can form a triangle. So all these concepts are contained within today's worksheet. The lesson recording is going to be uploaded into the portal. And at the same time, And at the same time, the solutions are going to be uploaded in the portal. So students, I'm sure there are some questions that you did not know how to do or you're not so sure. Make sure you watch the lesson recording, look at the solutions, and reinforce your learning. Okay? Now, Peter, I just need to ask you a question. Can you just stay for a while? The rest of you, Happy Chinese New Year. I'll see you after the holidays. Bye, everyone. Bye, Josh, Julian, Jin-Yi, Albert, Aiden, Asher, Surabi, Koji, Kyler. Bye. Bye, Aiden. Bye, Clarissa. All right.